All right, good morning. Chemistry Cantor here. I have some great information for you today. So, you may wonder to yourself, man, why is this, some off-ball number? 10.81, 22.990. So, the average atomic mass, the mass that we see on here is usually some crazy number. It almost seems random. So, how could titanium have a mass of this? So what we have to understand is that these are averages. This is an average of the different isotopes that exist in nature. So if you think back to the last unit, an isotope is the same number of protons with a different mass. So there's different forms of titanium. Here we have titanium. This might be 48, and we might have another one that has a mass of 47. Um, the one that exists the most in nature is probably going to be the 48, simply because it's closest to that number. So there are other isotopes of titanium, and then when we average those up, this is the number that we get. So we might only have 20% of the 47 titanium, and then the other 80% might be 48, or there might be three isotopes. We don't know. So, but there are different isotopes, and when we average all those together, and we also have to take into account their percent that we find in nature. So here, hydrogen is 1.008. So there are other forms of hydrogen, but the one that we see 99% of the time in nature is going to be hydrogen with one proton and hydrogen with one neutron. So that's what we'll see 99% of the time. All right, so let's take a look at. So here we can see we're looking at magnesium. So here we see magnesium has three different isotopes. So this is magnesium 24, 25, and 26. This one has 70%, 78%, so almost about 80%, and then 10% these two. So I'm thinking that when we do the average atomic mass of magnesium, we should see that this is closest to 24. These two are in smaller percentage, so they're a little bit heavier, so it's going to be 24 point something something. So let's take a look at it. All right, when I'm calculating average atomic mass, we have to take in account the percent that occurs in nature. So it's percent abundance. So this is fractional abundance. A lot of times we'll see that as percent abundance. And there you go. All right, so fractional abundance, percent abundance, same thing. So this is the percentage. This is what we're going to see 80% of the time in nature, 24. 10% of the time we're going to see magnesium 25. 11% of the time we'll see magnesium 26. So these ones are smaller percent abundance. This one is a larger percent abundance. So if we want to find out their mass contribution to the average atomic mass, we're going to take the mass and then we're going to multiply it by its percent abundance. These are in percent form. Let's go ahead and move these over into decimal form so we can plug it in the calculator. For decimal form, I remember that I'm going to take the decimal two places to the left. 1, 2. So for decimal form, we're going to use 0.787. All right, and then this is going to be 0.1013, 0.1117. All right, and then now we'll just plug and chug in the calculator. And so I'm going to take the mass of this one. Sometimes we'll also see this written as. So when we have the same atomic number, we put the mass number at the top, indicating that we know that these all have the same atomic number. The mass is what's fluctuating. Or you might see it as MG25. All right, so first thing we'll do is we're going to take the mass and we'll multiply that by percent abundance. That's going to give us the mass contribution. and then the mass contribution, that's what he's, once we get all of the mass contributions, then we add them up, and then that'll give us the atomic mass. So this is the percentage of Mg24, and then we have another percentage of 25 and 26 also. So let's just go ahead, we'll start on this one. All right, so Mg's mass is 23.985. And we're going to multiply that by this one, 0.787. And this is the and you got to have units. So pull out a trusty calculator. .985 times 0.787. And we're 18. And then the next one is Mg24, 25. That one's going to be 24.986. And multiply that one by 0.1013. That'll be 24.986. 1013. And then the last one we have is Mg26. Mg26 is 25.983. 0.1117. With 2.902. All right. And then once we have the mass contribution for each, to find the average atomic mass, I'm just going to add these numbers. So we'll do all right, and then we get 24.13. That was 3. And come here. See, the magnesium is 23.3. So this would be the average atomic mass. We couldn't measure up to this level of accuracy with the numbers that we were given, so we rounded off, and that was perfect. All right, and so that's a good example of how to do the percent abundance. We'll also take a look at if they give us the average atomic mass, can we go back and find percent abundance? So we'll look at that on part 2.